So in this video, we're going to review how to solve equations with a variable on both sides. So we're going to review how to solve multi-step equations with a variable on both sides, which I know is something that you learned back in Algebra 1, but it's something that we're going to need before we start solving equations involving absolute values. So this video is just to help you review. So remember, what we need to do is we need to go through these steps, and the mnemonic I use to remember these steps is don't call me after midnight. So we're going to distribute, then combine like terms, move all our variables to one side, and then add or subtract to isolate the variable, and multiply or divide to isolate the variable. So depending on your problem, you may need all of these steps or you may need just a few. But what you do is you go through these steps in this order, and if you don't need one, you just skip it and go to the next one. So for example, if you have a problem where you don't need to distribute, you'll just skip that step and start with combining like terms. So in the example given here, we have 2 times 5x minus 1 plus 5 equals 8x minus 1. So this example requires all of our steps. So we start off by distributing the 2 to everything that's in the parentheses immediately after the 2. So we get 10x minus 2 plus 5 equals 8x minus 1. Now we're going to combine the like terms, which we have this negative 2 and 5 on our left side of the equation. Those are going to combine to form plus 3. Now we need to figure out how to get all our variables on one side of the equation, so we're going to move the 8x to the left side. In order to do that, I need to do the opposite operation because that's the only way to move something to the other side of the equal sign. So I'm going to subtract 8x from both sides, which gives me 2x plus 3 equals 1. Now I can just solve this. I'm going to start off by using addition or subtraction. So I'm going to undo the plus 3 with a minus 3, and I do that on both sides, which gives me 2x equals negative 2. Now I'm going to divide both sides by 2, which gives me a final answer of x equals negative 1. So now let's work on some practice problems. So let's start off with 5 plus 2x equals 11. So this kind of problem sometimes confuses people because the 5 is in front of the 2x, which I know sometimes we're not used to seeing. But the thing to remember here is like what sign is in front of the 5. So that 5 is a positive 5, right? So it's basically like it has a plus in front of it. We just haven't written it. So when we're doing our opposite operation, we need to undo it with a minus 5. So I'm actually going to minus 5 on both sides of my equal sign, and that's going to give me 2x equals 11 minus 5, which is 6. So now in order to solve for x, I need to do the opposite of 2. So this 2x is another thing that often confuses people. Remember that 2x basically means 2 times x, right? It's just that I haven't written the multiplication sign there, but it's implied. So to undo the 2 times x, remember I need to do the opposite and I need to divide both sides by 2. So when I divide both sides by 2, that's going to leave me with x equals 3. And that's my final answer. Remember, whenever you're solving equations, you can always check your answer by plugging it back into the original equation. So for example, I can do 5 plus 2 times 3 and check if that equals 11. So that gives me 5 plus 6 equals 11. And that does tell me that 11 equals 11, which is true. So now let's try this problem. So remember, I have a variable on both sides, so I need to use my mnemonic, my don't call me after midnight. So I don't have any parentheses, so I don't need to distribute. I don't have like terms on either side, so I'm going to skip that step. But now what I'm going to do is I'm going to move all my variables to one side. Okay, so the convention is usually to have your variables on the left. If you want, you can move them to the right, but I would rather move my variables to the left. So I'm going to move my 8x, and remember I can do that by subtracting 8x from both sides. So when I do that, that's going to give me 10x minus 8x, which is 2x. So I have 2x equals negative 6. Now to get x by itself, I'm going to do the opposite of multiply by 2. So that means I'm going to divide both sides by 2. And that's going to give me x equals negative 3. So I can take that x equals negative 3 and plug it back into my equation to check. So I have 10 times negative 3 equals 8 times negative 3 minus 6. 10 times negative 3 is negative 30, and that equals negative 24 minus 6. So that means that my solution is correct. So now let's try this example. So once again, we have nothing to distribute, so I'm going to skip that step. I don't have like terms to combine, but I do need to move all my variables to one side. So here I have a 3x, and that is a positive 3x. So the opposite would be to subtract 3x from both sides of my equation. So when I subtract 3x from both sides, well, remember that I'm only going to combine the x's with x's, right? So the x and the minus 3x are what combine. And remember that x doesn't have a coefficient in front of it, but that basically means that there's a 1 there. So I do 1 minus 3x, so that's going to be negative 2x. So I have negative 2x, and then that plus 5 stays unchanged. And that equals, on the right side, these two terms cancel, and I have that equals 7. Now, in order to get x by itself, I need to work on adding or subtracting to isolate my variable. I have a plus 5, so the opposite of plus 5 is to do minus 5. So I minus 5 on both sides, which gives me negative 2x equals 7 minus 5, which is 2. Now I'm going to do my multiplication or division. So in this case, I have negative 2 times x, so I'm going to undo that by dividing both sides by negative 2. And that is going to give me x equals negative 1. So now that I have my answer, I can plug back in and check. That gives me negative 1 plus 5 equals 3 times negative 1 plus 7. Negative 1 plus 5 is 4. 3 times negative 1 is negative 3, so that does equal negative 3 plus 7, because I get 4 equals 4. So now let's try this example. So in this one, I see parentheses, so I know I'm going to need to distribute. But the question is, what am I distributing? So I just have a negative floating around here in front of x plus 8. So you can think of it as distributing a negative. If that confuses you, remember the number that's there, it's just not written down, is a 1. So it's basically like I'm multiplying both terms inside this parentheses by negative 1. So that's going to give me 5x plus 4 equals, well, negative 1 times x is just negative x, right? And then negative 1 times 8 is going to give me minus 8. So I've done the distributing step. So now what I need to do, I don't have any like terms to combine, so I'm going to skip that. But I need to move all my variables to one side. So the opposite of minus x is going to be to plus x on both sides. So I'm going to do that to both sides of my equation. So I have 6x plus 4 equals negative 8. And then now to get x by itself, I need to start off by subtracting 4 from both sides. So I subtract 4 from both sides and I get 6x equals negative 8 minus 4, which is negative 12. And now to undo that 6, I'm going to divide both sides by 6. And then I get x equals negative 12 divided by 6, which is negative 2. So remember, you can always go back and check. So I'm going to do 5 times negative 2 plus 4 equals negative of negative 2 plus 8. So 5 times negative 2 is negative 10. I have negative 10 plus 4 equals negative of negative 2 plus 8 is 6. So this is telling me that negative 6 equals negative 6, which is always true. So remember, to solve an equation with a variable on both sides, you can follow these steps. You can distribute, then combine like terms, move all variables to one side, then add or subtract to isolate the variable, and finally multiply or divide to isolate the variable. Remember, you may not need all of these steps, but we know whenever you have a situation like that, just skip a step and move on to the next one.